Two-sample mean tests for independent samples, also known as Waltz t-tests. We are going to compare the means of two groups, and we have some conditions. The first condition is the two samples are unrelated or independent from one another. The population standard deviations are unknown, and the variance of the first group cannot equal the variance of the second group. Both populations have to be approximately normally distributed. Samples greater than or equal to 30 will be considered sufficiently large to ignore any need to check for conditions of normality in the population. If the sample size is less than 30, then we have to check some conditions. We have to make sure there is no outliers using a box plot. And we have to ensure that the population is approximately normal by looking at the QQ plot and just confirming that it follows an approximately linear pattern. Then we know it's approximately normal. The 5-step process is exactly the same as earlier, and here is the formula to calculate the test statistic. T equals x bar of the first group minus x bar of the second group, divided by the square root of the standard deviation of the first group squared over the sample size of the first group, plus the standard deviation of the second group squared over the sample size of the second group. Now, this formula is if you want to do the calculations by hand. However, in our class, we're not going to do any more calculations by hand. Everything from now on will be done on StatCrunch. So we're just presenting the formula if you want to do it by hand. The degrees of freedom formula here is actually an approximation. The actual degrees of freedom look something like this. It is a massive, complicated formula. However, we don't need to use this formula in our class. We're just presenting it to you in case you want to do the work by hand and if you want to have some extra fun during the pandemic. But remember, we're going to use StatCrunch for everything from now on, so we don't really need to know the formula. The confidence interval for a two-sample mean test is given by the following formula. Again, we're going to use StatCrunch in our class, so we don't really need to know this formula at all. If the degrees of freedom is greater than 1,000, we're going to use our Z statistic, which is given by this formula. And similarly, for the confidence interval, we will use our Z statistic in place of our T statistic when we're doing a confidence interval. But again, we're going to use StatCrunch, so we don't really need to use these formulas. Let's try example 1. Test the claim that the mean number of units taken by COS male students is the same as the mean number of units taken by female students at the alpha equals 0.05 level of significance. The results are as follows. So we have a table that tells us the sample size, the sample mean, and the sample standard deviation for both of the groups. Since we're talking about a two-sample mean test, since there are two groups, we need to let the reader know which one's group 1 and which one's group 2. So I always let the first one that appears to be group 1 and the second one that appears to be group 2. So let's let males be group 1. And we'll let the females be group 2. It is important that you let the reader know which one's group 1 and which one's group 2 so you can correctly state your null and alternative hypothesis. Okay, so let's start the problem. We're going to look at the claim and the complement. We are claiming that the mean number of units taken by COS male students is the same as the mean number of units taken by female students. So the claim is the mean of the first group is exactly equal to the mean of the second group. The complement to this is the opposite, so the mean of the first group is not equal to the mean of the second group. And now we can start step 1. We'll state the null and alternative hypothesis. Remember, the null hypothesis is always the one with the equal sign. So we'll let that be the claim. Mu1 is equal to mu2. For the alternative hypothesis, it's going to be the complement. Mu1 is not equal to mu2. Step 2, we're going to state alpha. Alpha is equal to 0.05. Step 3 and 4, we're going to use StatCrunch for this. Notice, looking at the alternative hypothesis, this is a not equal symbol. So if we were doing this by hand, we would reject the null hypothesis if it's too high or too below, and we would have to double the p-value. But since we're doing this on StatCrunch, the doubling is done for us on the computer. We're going to try the question now on the computer. Make sure to select the calculator that says 2 independent samples with statistics. Now for the first group, the sample size is 35. The sample mean is 12.8. And our sample standard deviation is 3.4. For the second group, we have the sample size is 40. And the sample mean is 11.5. The sample standard deviation is 3.5. And now you want to select the correct alternative hypothesis. In our case, it's not equals for HA. And I'm going to also at the same time do a level of confidence, since that's going to be the second part of this question. So let's do a 95% level of confidence as well. And then we'll click calculate, and here is our test statistic, about 1.629, our p-value about 0.10759, and we have our lower limit and we have our upper limit. Our lower limit or our lower bound is negative 0.29 and our upper bound is 2.89. Our t-stat is 1.629 and our p-value is equivalent to 0.108. Now remember, the computer did the doubling for us, so we don't have to double the p-value. In step 5, we're going to state our conclusion. I always ask myself, is the p-value less than alpha? Is 0.108 less than 0.05? No, it is not. So we do not reject the null hypothesis. We do not reject the null hypothesis. There is not enough evidence to conclude. And our conclusion is always in terms of HA. And HA states that mu1 is not equal to mu2. So we're going to state there is not enough evidence to conclude the mean number of units taken by COS male and female students is not the same. Since the p-value is not less than alpha, we do not reject the null hypothesis. There is not enough evidence to conclude the mean number of units taken by COS male and female students is not the same. The lower limit is negative 0.29 and the upper limit is 2.89. Notice that in the interval there is a 0. 0 is in the interval. What that means is we are going to have no difference. When we do a two-sample mean test, we're actually taking the difference between the averages. And we are 95% confident that there's going to be a 0 inside the interval. So we're going to write, we are 95% confident that there is no difference between the mean number of units taken by male and female students. We are 95% confident that there is no difference between the mean number of units taken by male and female students. If there was no 0 in the interval, we have a different scenario. And in the next example, we'll explore the scenario where there is no 0 in the interval.